ਇੱਕ ਓੰਕਾਰ ਸਤਨਾਮ ਕਰਤਾ ਪੁਰਖ ਨਿਰਭਉ ਨਿਰਵੈਰ ਅਕਾਲ ਮੂਰਤ ਅਜੂਨੀ ਸੈਭੰ ਗੁਰ ਪ੍ਰਸਾਦ। God is everywhere and in everyone. He is truth, immortal, creator, without fear, without enemy, unborn, self-created. This understanding comes by the Guru's grace. By the Guru's grace, I am going to start unit number 5, Surface Chemistry. Unit number 5, Surface Chemistry by Amrik Singh, PGT Chemistry. Surface chemistry, adsorption, adsorbate and adsorbent. Basic concepts. Surface chemistry deals with phenomena that occur at the surface or interfaces. सरफेस केमिस्ट्री डील करती है फिनोमिना के साथ जो सरफेस पे होता है। Adsorption, the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid, is termed as adsorption. Adsorbate, the molecular species which concentrates or accumulate at the surface, is termed as adsorbate. Adsorbent, the material on the surface of which the absorption takes place, is called adsorbent. Let's have the animation, and we are seeing the molecules are settling on a surface. These molecules settling on the surface are adsorbate, and the surface on which adsorbates are coming is adsorbent, and the whole process is known as adsorption. Adsorption in action. There are some examples of adsorption. If a gas like O2, H2CO, Cl2, NH3 or SO2 is taken in a closed vessel containing powdered charcoal, it is observed that the pressure of gas in enclosed vessel decreases. The gas molecule concentrate at the surface of charcoal and gases are adsorbed at the surface. Second example is in a surface of an organic dye, say methylene blue, when animal charcoal is added and the solution is well shaken, it is observed that the filtrate turns colorless. The molecules of dye thus accumulate on the surface of charcoal are adsorbed. Aqueous solution of raw sugar when passed over beds of animal charcoal becomes colorless as the coloring substances are adsorbed by the charcoal. Fourth example is the air becomes dry in the presence of silica gel because the water molecule get adsorbed on the surface of the gel. Mechanism of adsorption. Desorption. Let's first discuss the mechanism of adsorption. On the surface, the particle possesses unbalanced or residual attractive forces. These forces of the adsorbent are responsible for attracting the adsorbed particle on its surface. Let's have the animation. We have some liquid, and in the middle, in the bulk, the net force is zero, but on the surface the net force is not zero. There is unbalanced force. This leads to the polarization of molecules on the surface, and hence it attracts the gas molecules which are polar in nature rapidly, which are non-polar in nature slowly. Now, desorption. The process of removing an adsorbed substance from the surface on which it is adsorbed is called desorption. Let's have animation. We have some particles which are adsorbed on the surface. That is, now we are explaining desorption. These molecules are leaving the surface one by one. The process is known as desorption. Distinction between adsorption and absorption. In adsorption, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the adsorbent. While in absorption, the surface is uniformly distributed, so the substance is uniformly distributed throughout the bulk of solid. For example, when chalk stick is dipped in ink, the surface retains the color of the ink due to adsorption of the colored molecule, while the solvent of the ink goes deeper into the stick due to absorption. On breaking the chalk, it is found to be white from inside. Let's have the animation. There are some molecules which are adsorbing on the surface. This is representing the adsorption. We are still seeing that some molecules are accumulating on the surface. Now red molecules are penetrating to the bulk, and this is known as absorption. Particle at surface, particles in bulk. Types of adsorption is of two types: physical adsorption and chemical adsorption. Weak van der Waals forces are present between adsorbate and adsorbent in case of physical adsorption. In case of while chemical adsorption, strong chemical bonds are formed between adsorbate and adsorbent. Point number two, physical adsorption has low heat of adsorption, while chemical adsorption has high heat of adsorption. Point number three, multi-layers of adsorbed particle are formed in case of physical adsorption, while in case of chemical adsorption, mono-layer of adsorbed particle is formed. Point number four, it is not specific in nature. Physical adsorption is not specific, while chemical adsorption is specific. Physical adsorption is reversible, chemical adsorption is irreversible in nature. Physical adsorption is inversely proportional to temperature, while chemical adsorption is directly proportional to temperature. Let's have the animation of physical adsorption. Molecules are adsorbing on the surface by weak van der Waals forces. Now let's have the animation of chemical adsorptions. The molecules will adsorb on the surface through the chemical bond. The cones represent here in animations the chemical bonds. Chemical bond. Physical adsorption and chemical. Factor affecting adsorption. Nature of the adsorbate and adsorbent in general. Easily liquefiable gases, for example CO2, NH3, Cl2 and SO2, etc., are adsorbed to the greater extent than the elemental gases, for example H2O2, N2, Hg, etc. Surface area of the adsorbent. The extent of adsorption is directly proportional to the surface area of adsorbent. Surface area is inversely proportional to the particle size. Effect of pressure on the adsorbate gas. Adsorption is directly proportional to pressure. Effect of temperature. As adsorption is accompanied by the evolution of heat, so according to Le-Chatelier principle, the magnitude of adsorption should decrease with rise in temperature. Freundlich adsorption isotherm. Freundlich in 1909 gave the empirical relationship between the quantity of gas adsorbed by unit mass of solid adsorbent and pressure at a particular temperature. The relationship can be represented by the equation x by m k p raised to power 1 by n is greater than 1, where x is the mass of gas adsorbed on mass m of the adsorbent at pressure p. K and n are the constants which depend on the nature of the adsorbent and the gas at a particular temperature. Let's have the graph between x by m and p is friendly adsorption isotherm. Taking the logarithm of the above equation, then we get the equation log x by m log k 1 by n log p. The validity of French-lit adsorption isotherm can be verified plotting log x by m on y-axis ordinate and log p on x-axis. If it come out to be straight line, the French-lit adsorption isotherm is valid, otherwise not. Is found to be valid. Graph is shown here. Failure. Experimental isotherm always seem to approach saturation at high pressure. This cannot be explained by French-lit adsorption isotherm. Thus it fails at higher temperature. Applications of adsorption. There are many applications of adsorption. You are seeing one by one in the slide. Yeah. Many application: production of high vacuum gas masks, control of humidity, removal of coloring matter, heterogeneous catalysis, manufacture of ammonia, manufacture of H2SO4, separation of inert gases in curing disease, froth flotation process, adsorption indicators, chromatographic analysis. Exercise. There are many questions which we have covered. The student should know about these questions. These may be asked in the examination. There are total 11 questions in NCERT book regarding this topic, and these may be asked in the examination. Thank you. Thank you.